the angle of depression of the top and the bottom of a tower are observed to be 30 and 60 respectively. Find the height of the tower. Yeah. So it's a CBSE question. It was a CBSE PYQ, CBSE 2005, which is given in RD Sharma. So I'm giving you 3 minutes to solve this question. It's a very easy question. It's like the question which we have already done in the class. You just need to draw the figure of that basically statement. Okay. The angle of elevation and angle of depression is given. Okay. Okay. Everybody.
Yes, sir.
Okay, so what you need to do is that you need to find out the tower length, tower height. Clear? Solve it, giving you 3 minutes to solve this. Okay. Then everybody? Any answer? Everybody? What happened, everybody? Why is everybody silent? Any response? It's a easy one, everybody. Yeah, just look at them. So it's basically saying that you are standing. So it's saying that you are standing at the top of a tower. Clear? So basically it's saying, and you are basically say from the top of a building, 60-meter high. So 60-meter high is already given.
Yes, sir.
Yes, now just a second. It's saying that the angle of depression of the top and the bottom of a tower are observed to be 30 and 60 respectively. Find the height of the tower. So height, basically the height of the tower, basically, just a second. It will be greater, yes or no? Everybody?
Yes, sir.
Sure?
Yes, sir.
Any doubt?
No, sir.
Just give me a moment. Let me have some water actually. Yes, everybody. So, is my video visible to all?
Yes, sir.
Yeah, actually. Yeah. So let's take, so it will be a little, just join the lines here. It will be like this. It's here. And it's here. So question is basically saying that from a top of a building, the height of the angles, the angle of depression from the top and the bottom of a tower are observed to be 30 and 60. So basically now you can see that. So this angle basically from the bottom of a tower is nothing but the angle of, just a second. Actually, I'm a freehand drawing, so like this. Okay. So this will be what? Can anybody tell me what is the value of this angle and this angle? Everybody?
38 degree and 60 degree.
This one is what?
60.
60. Yes. And this one is 30 degree. Clear?
Yes,
So now, just a second. And this is what? Let's take this value, like nothing is given here. So I can take this x as like as x. Clear? Any doubt? Everybody,
No,
yes
sir.
or no?
No, sir.
Yeah. And suppose what we need to find out the height of the tower. So basically this will be h. Yes or no?
Yes, sir.
Basically the height of the building is given, which is of 60 meter. 60 meter. This is the value given here. 60 meter is given. Clear? So this is h. So what will be the value of this part? Everybody? Yes, everybody, tell me what will be the value of this part that I've drawn?
So
60.
60 minus 90. No.
Okay.
Sir, 60 minus h.
60 minus h. Very good. Why? Because total is 60. And if I subtract the h1 height, so I will get only 60 minus h. Yes or no? 60 minus h. Yes or
sir.
no?
Yes, sir.
Clear? So you can directly, so let's name the triangles A, B, C, D, and E. So these are the points. Okay. And what we need the basically h. Clear? So tell me, everybody, can I find the value of x from this triangle ECB? Triangle ECB. This whole triangle, this 60-degree triangle, ECB, because 60 is given, x is not given, 60 is there. Yes or no, everybody?
Yes, sir.
In triangle ECB, tan 60 degree is equals to what? Tan 60 degree is equals to EC by BC. Yes or no?
Yes, sir.
Yes, sir.
EC is 60, BC is x, and tan 60 is what? Who can tell me the value of tan 60? Why is everybody silent?
Root 3.
Root
3.
3. Very good. Root 3 is equals to 60 by x. So what you will do, you will just cross multiply them. 60 by root 3. And if you need to rationalize the denominator, you will just multiply and divide. Yes. So it will be 20 root 3. So 60 root 3 by 3. So it is equal, x is equals to 20 root 3 meter. Clear? So the value of x is given. So if this is x, so it will be x, obviously. This will also be equals to x, basically this part.
Yes, sir.
I need basically this part because I need to apply the trigonometry in a triangle EDA. Clear?
Yes, sir.
So that's why I need the base. So can I write in triangle EDA tan 30 is equals to what? ED by DA. And ED by DA is nothing but 60 minus H upon X. Yes or no, everybody? And
Yes,
tan
sir.
30 is 1 by root 3 is equals to 60 minus H is 60 minus H upon is what? 20 root 3. 20 root 3. Okay. So just you will need to do, you will just cross multiply them. So 60 minus H will be equals to 20 root 3 by root 3. This will cancel, yes or no? So your 60 minus H will be equals to 20. So basically just shift, shift the H towards the right side and 20 on the left hand side. So 60 minus 20 equals to 40 meter. Clear, everybody? That's your answer. The value of this is 40. Clear?
Yes, sir.
Is there any doubt? How
No,
many of you
sir.
have got the answer? This 40 meter? How many of you got the answer? Be honest.
Sir, I got the answer, but I didn't use that H and X.
So
I just
what?
put the formula.
So okay. So Karishma, the one thing is that like dear, you have to make the steps in the exam. Like without steps, you are not going to get the marks. Like teacher will like you will get the marks, but teacher will deduct the marks on the basis of the steps. You
Okay,
have to
sir.
mention each and everything like you what you are taking. Like you have seen, like I didn't write like that. Let's suppose BC as X. Like you have to keep that thing in your mind that you have to write the thing. Because teacher will say what is X. Clear? So that's why just a little bit more you can say precise about the while writing the answer. Clear?
Yes, sir.
Any doubt?
No, sir.
Okay, very good. So that's what the like we are done with this chapter. Okay. So have you like in the previous class have you have you attempted the assignment? Was there any assignment in the previous class of the trigo? I just don't remember that like I didn't remember that. Did you have any assignment in the previous class of trigonometry introduction, this application of trigonometry?
Yes, sir.
Okay, okay,
Yes, sir.
okay. No issues. I was just asking like whether it's yes or no.
So can you scroll a bit up?
Yes. Just give me a minute. Is that clear?
Yes, sir. Thank you.
Just give me a second. Let's start the new chapter. So, okay, almost half an hour is gone. So I need I want to start the chapter so that so how many of you have the proof of the theorems in your schools?
So I have.
You have.
Right.
Okay. Hiba
So like
has
what theorem? So which
triangles
theorems are we
theorem.
talking about?
Triangles theorem.
The
Okay, Adil.
BPT one?
Yes,
BPT one?
BPT, Pythagoras.
Yeah, converse of BPT also.
Converse of BPT is nothing but it's just a statement.
Yeah. Yeah, sir, I have
Yeah.
all.
So you have all. Okay, Hiba
Very
has all.
well.
Adil,
Yeah, very good.
Adil has all.
Yes, sir.
Yes.
Yes, sir.
Okay, Karishma. Okay, so Abdullah, Adil. So everybody has their like basically the proof of the BPT and all the theorems like the Pythagoras and all.
Yes, sir.
Okay, that's all. I just wanted the confirmation that how many of you have the proof. So I just need just a second. Let me aside this book. Okay. So let's start the similarity, like basically the what similar triangles are, like all the things. Let me name the topic. Similar figures. Okay. So let's understand what basically similarity is. Okay. So now tell
Sir, the chapter I have like finished on this question. Was this the last question?
yes, Abdullah, you were saying something. Yes, please repeat that.
Sir, I said like was this the last question for application of trigonometry?
Yes, almost last. We are done with that.
Okay, sir. Okay.
I just thought that I should do some like the RD Sharma question. Like we have already consumed half an hour in the one question, so I don't like. I should like. I thought that I should start the triangles because we are a little bit behind the. You can say. I thought that I should complete this chapter by now, the triangles chapter, but we are starting right now. So okay.
Okay, sir.
Okay.
Thank you.
So I will like I've shared the P like you can in the app PYQs are there, so you can attempt that, and if you have any, you can say any doubt or anything which is not clear to you, come to me, just like the Karishma did in the previous class. She had a doubt. She sent me the picture, and I've cleared her doubt in the like after the class. So you can also do these kinds of things. Okay. Clear, everybody?
Okay.
Yeah.
Yes, sir.
Okay. So let's do that thing as well. So basically now it's a rectangle, and one more rectangle is just placed beside this. So now the dimension are a little bit different, you can say. So this is 6 centimeter, 4 centimeter, and this is, you can say, 5 centimeter and 2 centimeter. So now tell me, are they equal?
No, sir. They are similar, not equal.
Yes. So basically they are similar. Why? Because I will say that it is a triangle as well. I will say that it's a triangle as well. Yes or no?
Yes, sir.
Yes.
Any doubt in this?
No, sir.
Okay. So let's take one more example, because I want that you should be very clear about the concept, what is basically similar and what is basically equal. So this is a circle, and the radius of the circle is nothing but, let's suppose the circle is 5 it's of 5 meter, it's of 2 meter. So now tell me, everybody, are they equal?
No, sir.
No?
No, sir, they're similar.
It means that they are similar. Similar figure means basically they are representing, the figures are basically the shape of the figures are same, but that doesn't mean that the dimensions are also same. Clear? So that's what the similarity is. In like similarity can be there in any figure. It's triangles, it's rectangle, it's circle, it's polygon, it's trapezium, anything. Similarity just only says that the shape is same. Like suppose that I'm a human, you all are human. We have a similarity is what? We are humans. Yes or no?
Yes.
Yes, no?
Yes, sir.
Yeah. So, but if I say that I'm equal to Abdullah, so it's not possible,
Yes, sir.
because we have different factors, and like all the things are like my face cut is different, my haircut is different, Abdullah has different haircuts, everything is different. Only with the similarity is that we are humans, and the similarity is that we are boys. Clear?
Yes, sir.
That's all. That's what similarity is. So basically, there is one more. So you have this. You can say we have to apply this similarity in the triangles part as well. Clear? So I'm just basically, just give me a second. I'm just pasting a picture. So after that, you can tell me whether it's Just give me a second. I'm pasting it. So it's the so yes, here is the insertion part. So everybody tell me the correct option one by one. Yes, one by one. Everybody, I want the answer. What should be the first fill in the blanks?
Similar.
Similar.
Similar. Why?
Not
So similar for second one also is similar, and
Okay.
for third one,
isosceles.
all isosceles triangles are similar.
Okay. Okay. Isosceles. Okay. So okay. So third one is a little bit okay. So you all said one by one said so Hiba, Abdullah, and Karishma said isosceles, right? Yes or no?
They're all equilateral triangle.
Okay.
No.
So Faz is saying
Equilaterals.
equilateral.
They're equilateral.
Okay. Don't change your answer. If you are on the isosceles, just what's your first answer beyond that? Okay, I'm not like basically you're not getting any reward at this point of time. Like if you change your answer, you will get so just so if you said you think a little bit and then you said right.
Yeah.
That's the thing, yeah. So basically now tell me now let me take one thing here. You are saying suppose this is a equilateral triangle. Okay, this is another equilateral triangle. Because isosceles like similarity is a little complicated, you can say. You will see that things are equal and also you will say that this is why it is similar, it's not equal. So just a second, it's a isosceles. Another isosceles is of small height. See, the dimensions are different. Okay, so now tell me, suppose this is 6 centimeter, this is 6 centimeter, angle is 30 degree, angle is 30 degree. Clear? This is, you can say 6, not 6. This is 4 centimeter. This is 4 centimeter. Angle is suppose 25 degree. So this angle will be 25, yes or no?
Yes, sir, similar.
Yes, sir.
Now tell me. Now let's come to the part of equilateral. This is 60. 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 And this is 60. Now
No,
just
sir.
look at the thing. What is the difference between them?
Sir, if we take a look from this chapter, then I think the equilateral one will be considered congruent because all the angles are equal. But
Not
we are
congruent.
talking about
Not congruent.
yeah, we need
That's
the sides also. We need the sides also to be
yes.
equal. But like
Congruence.
if
Yeah.
in this chapter we are looking for similarity, so I think isosceles.
Okay, so okay, so you said that we are looking for similarity. Congruency is what? Congruency means that they're symmetrical. If I'm saying that my hands are congruent, they should be equal. Now tell me, are they equal or not? Are you able to see my behind one hand? No, na? You are able to see only my front hand. It means that they are congruent. They are basically representing that each and every point of this figure is equal to the next figure. Yes or no?
Yes, sir.
Any doubt in this?
No, sir.
Yeah. So basically that's what is defining. And similarity means that you can see that similarity means you can see that 60, 60, 60. Equilateral triangle have the same property. You can see that the angles are same. All whether it's like, I'm not saying whether it can be any side, like the dimension of the sides can be anything of the equilateral triangle. You can see that angles are also equal. Yes or no?
Yes, sir.
Yes,
So,
sir.
but in the isosceles triangle, if you see that isosceles triangle in comparison to this, you see that the isosceles triangle can have the different angles and different sides. Yes or no?
Yes.
In similarity, there is one criteria which is angle, angle, angle. It means that if the three angles are similar, if the three angles are equal to other figure, this means that the triangles are similar. So that's what equilateral triangle follows. You can see that angles are equal. I'm not saying that at any side like it's 4 centimeter or 6 centimeter. I'm just taking that you can see that the equilateral triangle will have 60 degree at any cos, whether it can be of any size. Clear? But isosceles triangle have different can be different angles, different sides. Clear? And now just take the example of the circle, na? Sorry, rectangle. Now tell me, the angles are 90, 90, 90, 90, 90, 90, 90, and 90. Tell me,
Similar.
similar? All the angles
Yes,
are
sir.
equal. I'm not just saying that it's on the side.
Yes, sir.
Clear?
Yes, sir.
Have you got this point, everybody?
Yes, sir.
So that's how basically you will identify whether it's similar or not. Okay?
Yes, sir.
Yes, sir.
Okay, that's great. So that was the basics of the similarity of the triangle. Now you can see that it's a little bit tricky, na? You just got confused.
Yes, sir.
Okay. So we have the two statements if the triangles are similar or not. Clear? So let me write those the thing, just a second. This is the next step. Similarity of triangles. So basically, two triangles are similar if the two conditions are there. If first part is if their angles, corresponding angles are equal. Clear? Second is if the ratio of their corresponding sides are same. Everybody got it?
Yes, sir.
Yes, sir.
There corresponding sides are in so the second example basically represents that, like suppose that this is a triangle. Okay, this is another triangle. Okay, so suppose that this is 6 centimeter, this is 6 centimeter, and this is again 6 centimeter, and this is you can say 4 centimeter, 4 centimeter, 4 centimeter. It means that just take the ratios of this side. This side will be taken with this side, the ratio 6 by 4 here equals to Another ratio, this side will be taken with this side, clear?
Yes, sir.
So
Yes,
this
sir.
will be 6/4 and this side will be taken with this side. 6/4. Now
6
you
by
can see
4.
that this is nothing but 3/2. All the sides are in same ratio. Clear?
Yes, sir.
Any doubt?
No, sir.
No, sir.
That's what the second line represents. Clear?
Yes, sir.
Any doubt here till now? Everybody?
No, sir.
No, sir.
Okay.
So can you just scroll once again?
Yeah, sure.
Copy
Is
the
that
point.
yes, sure. How many of you note down the points?
Done, sir.
Okay, that's good. Please note down the points as well here. Like it's a request to all of you, because writing on your own is a very good thing to learn, very good habit to learn. Okay. So I don't think that I will be able to, you can say, complete the BPT in this class itself, because if I start, I need to end. So the proof will be like I will take the proof in that upcoming in the tomorrow's class. I'm writing down the statement of the BPT. Clear?
Okay, sir.
Everybody. Is that clear to everybody? Any doubt?
Yes, sir.
No, sir.
Okay, just give me a second. Because I need to explain, like BPT is a little tricky. So I need
Yes,
to
sir.
explain in a detail. So I will take that thing in the next class. So basically, let's theorem 6.1 is nothing but BPT. Basic proportionality
Basic proportionality theorem or
theorem.
Thales theorem.
Yes, very good. Thales theorem. So it's commonly said as BPT. Clear, everybody?
Yes,
It
sir.
says that if a line drawn, if a line is drawn parallel to one side, parallel to one side, for triangle. Clear? If I'd say, if it's saying that the line, basically if a line is drawn parallel to one side of a triangle to intersect the other two sides, at distinct points. Points are distinct means different points. Like this point will be different and this point will be different. Clear, everybody?
Yes, sir.
Distinct points. Then, which means that other two sides, the other two sides are divided in the same
Same ratio.
ratio. Very good. Clear? So basically, this is what the BPT says. So let's suppose that, let me give you the just I'm explaining that to you, so that in the next class we'll just directly start the BPT proof. Okay, so I'm explaining that part to you right now. So now everybody tell me, it's A and this is B and this is C. Okay, clear? Yes or no?
Yes, sir.
Yes, sir.
So if I basically do what? If I make a line parallel to one side of triangle. So now Hiba and everyone, Hiba, Abdullah, Karishma, Adil, Faz, if I make a parallel line, this line would be like this, yes or no? Just a second.
Yes, sir.
let me take a 2 arrow side. It will be like this, yes or no?
Yes, sir.
Yes, na? Suppose that is D and this is E. Okay, so that is D and this is E. It means that if the question, basically the theorem says that if they are like, if the line is parallel and it is these are two distinct points, clear? So it means that the two sides are divided in the same ratio. It means that AD by DB, two sides, this side and this side, and AE by AC should be equal.
Equal.
Clear? So basically to prove, what we need to prove is that to prove what we need, basically we need AD by DB equals to
AE by
By
EC.
EC.
EC. Clear? That's what
Yes, sir.
we need.
Yes, sir.
Any doubt in this?
No, sir.
Sure.
Yes,
No,
sir.
sir.
So how many of you know that triangle, basically, just a second, triangle made on the same base have equal area and between the
Yes,
same
sir.
parallel line? Ninth class area of parallelogram. I think that this chapter has been omitted, right, like this year. Area of parallelogram. Area of parallel, not area of parallelogram, area of triangle, sorry. Area of triangle. That was the chapter name, area of triangles. So there was a chapter. So that theorem was that just keep that thing in your mind. If the triangles are on the same base and between the same parallel line, okay, so they have the same area. Clear?
Yes,
Okay,
sir.
everybody? Any doubt?
No, sir.
No,
No,
sir.
sir.
Okay, very good. So that is the basically the what we need to prove is that this thing. So what we will do, I will just giving you the idea. We will do nothing but I will drop one perpendicular on this side to calculate the height of the triangle ADE. Okay, basically area of triangle is what? Half base into height, and height is what? Perpendicular.
Yes,
Yes,
sir.
sir.
Yes or no?
Yes, sir.
Very good. And I will draw another perpendicular which is on this triangle. Clear?
Yes, sir.
So this will be 90. Okay. Is that clear to everybody?
Yes, sir.
Very
Yes,
good.
sir.
And two triangles which are between same parallel line are these triangles basically. This triangle basically, just a second. This triangle is basically yes or no?
Yes, sir.
And this one triangle, which you will within the triangle will be on the same base. Now you can see that DE is the same base of the triangle BDE and triangle DEC. This is DE is common, na? BDE, DEC. This is the between the same parallel line. These are in the same parallel line. Yes or no, everybody?
Yes, sir.
Any doubt?
No, sir.
Sure.
No, sir.
Yes.
Yes, sir.
That's what we need to do. Clear? Yes, everybody?
Yes, sir.
Okay, that's great. So that's what like basically the PPT says. So I've just given the introduction and what we will be doing in the next class. That's like I've drawn the figure to explain what things we will be we will be needing. I'll explain why we are drawing the perpendicular and why we need to take the area triangles on the same base. Clear?
Yes, sir. So you didn't denote the alphabets for those 90-degree angles.
Not denote, it's a 90 degree, it's a square sign this, like whenever the angle is 90, it's a sign this which we make.
Okay.
Okay.
No, actually, sir, in the textbook it was like NMN.
Okay, we will do that naming as well, dear. But right now, I'm not doing any naming because like I know that it's like not possible to complete BPT. It's a lengthy theorem because it's explaining, but it will take a little bit more time. Okay.
Okay, sir.
So it's you can say lengthy theorem to prove. So that's why I thought that I should take this in the next class, which is the tomorrow's class. Okay. And after that, we will be doing the remaining part of the class. So I think that it will take 3 classes to complete. I think so. Like it depends on the number of questions we will take. So I will try to complete all the types of question which is there in the syllabus. Okay.
Okay, sir.
Okay,
Okay, sir.
that's great, everyone. So that's all for this class, everybody, and thank you so much for joining the class on time. And I'm requesting everybody to be on to be consistent and regularly practice the previous chapters what we have covered so far: AP, trigonometry, and linear equation and polynomials. Clear?
Yes, sir.
Yes, sir.
Okay, that's all. Thank you so much, dear, for everyone.
Thank you, sir.
Welcome,
Thank you,
dear.
sir.
Welcome, dear.
Sir,
Okay,
there is
yes,
no
no
assessment.
assessment. Like after it's an introduction because half an hour class will not cover so much topic, so that's why.
No, for
Yes.
application
No,
of
no
trigonometry.
application. So you had the assessment in the previous class of applications of trigo.
Okay.
Yes or no?
Yes, sir.
Just a second. Like, let me check whether you have like the trigo or not, like assignment of trigo or not. Just give me a moment. Your class was on Wednesday. Just a second. No, you didn't have any in the previous class. You didn't have any assessment here.
Yes, sir. That's
So that's
you
what
said
I
that
was continuously asking. But
you said you
told
would take next class after
Okay,
RT
okay.
Sharma questions.
Okay. Joe, okay. So one more thing, just give me a second. Just give. Just a second. Don't leave the class. Okay. So, Karish, so Abdullah and Hiba, so the test is active. You can attempt the test. Okay, so management will also inform to all. So you can go and attempt the test here. Okay, the test is active.
So
Yes, sir.
now,
Yes, now.
so which test?